Oh, hi there. We're glad you're watching one of our virtual lunch presentations. We have a lot of good information that we've been accumulating over the past several years, and we invite you to look down just below here and hit the subscribe button, and the little bell will give you a reminder of when our next presentation is published here on the YouTube channel. Thanks for your support. Appreciate it. We're pleased again today to have Jeff Welton with us. If you haven't noticed already, Jeff is the good guy from Nortel. 30 years of customer support, sales support, and generally talking to us about things that matter and sharing his expertise. And today we thought the idea here, being in compliance, this is another one of those areas in which, like an FM antenna, you see it when it's delivered, and then it goes up there, sometimes several hundred, sometimes several thousand feet, and you never see that antenna again unless a tower crew brings back a picture or a drone shows you where the lightning hit. There's this big hole in the antenna. Other than that, it sits up there and you don't do a whole lot with it. The transmitter, on the other hand, gets the same treatment in many cases. It comes off the assembly line, it's tested, it meets all specifications, but now what happens? The FAA is calling. The ATC is hearing country music and wants to know why you're doing that. How could that happen? And what do you do? That's kind of where we'll take off from and go from there. Jeff, what's your opinion here on this one?
Of course, you got me when I'm playing with stuff and not, or mute. I actually muted for a change.
Yeah, but you did hit the X this time.
I didn't hit the X this time. So we're going to call that a win. The old dog can learn from his mistakes sometimes. The biggest challenge, and this, whether it's old gear, new gear, I mean, I told somebody once, they go, oh, it's solid state, this will always be right bang on. And it's like, yeah, it'll be right on that frequency, might be on that frequency, could be on that one over there too. So you do still need to be able to monitor this stuff. The power would be another good example. You know, a transmitter is putting out this many watts of power, but if you throw some ice on the antenna, not all of them are going up the pipe. Some of them are coming back, and at that point, all of your power meters, assuming they're capacitively coupled, are inaccurate. So, you know, I guess the question, and I didn't want to put this up with me being the expert, because I can see 20 people in this room already who are smarter than I am in this regard by a long shot, maybe even more. So, you know, how often is as often as required to maintain compliance, which is exactly what the rules say, which is just the FCC creating a wiggle room to say, yeah, no, we're not going to tell you how often it's got to be, but if it's not right, we're going to come knocking, as if there was enforcement folks. Is Lark on today? I haven't noticed, so I don't want to be dumping on him if he is.
Well, one of the things, and I'll just spring off your last remark. Yes, the phrase is in the rules as often as required. It reminds us that we should have transmitter logs of some sort. If the commission agent comes in and says, you're over power, and you can't show him that it was okay yesterday, the day before, it puts you in a pretty embarrassing place.
Yep. Now, the interesting thing, and I'm sure I see a few faces here where I may have heard stories of this nature from over the years, is when you go look at the logs and the readings are identical to the day before and the day before and the day before, and you already know that 2 days ago you would shut the transmitter off during the shift change for maintenance. So there was no way it could have been showing as on at full power with no reflected at this time. Because, you know, when you get humans involved, sometimes it's like, okay, we'll just write down yesterday's numbers and call it a good day.
They do that. They do that. So, and then when they get the decimal in the wrong place, it stays.
Yeah.
I showed up at a station once to run the night shift, and there were perfect log readings all day. It was supposedly non-directional, but it had been directional all day.
Yeah. Bill, you've got your hand up there.
Yeah, Jeff, I've been using SNMP to monitor, and I'm using MRTG, which keeps all the logs in a table, so I can go back years and reconstruct a graph or look at a specific value, assuming, of course, that the calibration of the VS 2.5's stuff is pretty accurate, and I'll assume for the moment that it is. Do you have experience where things are not as reported?
So typically, the power probes that we use on those are pure directional couplers. I mean, we're not dealing with plastic caps or electrolytics or things that typically age. So if they do go off, that would tend to be indicative of an actual physical failure, and it's going to not go off by a little bit, it's going to go off by a lot. Where you might potentially, and I mean, I'm going to call us out on it, but because that's the shirt I'm wearing, but it would apply to just about any current manufacturer. There are situations where you could theoretically do a massive software upgrade. Maybe you had to replace a controller module or something. And if it didn't read the calibrations right, because most of the times where we used to calibrate stuff, you remember the old meter movements, you'd have the big old meter movement with a little circuit board on back, and there'd be a trim pot so you could tweak the meter readings. And these days we do that by setting a digital field in a software file. So if you do an update and it blows that calibration setting out, then that could be an issue. To date, we have not done an update that blew those out. So, knock on wood, so far so good. But again, that's something that you do want to keep an eye on. So it's like I've said before with field mods. If you aren't doing the software updates, then it's the same as not doing the physical field mods we used to ship years ago. But you do have to do just sort of a quick once over, is everything working right, after you do the software update too.
Well, let's start at the simple end here.
Yeah.
We have a Nortel transmitter.
Okay.
Yeah, many of us do. And there is a GUI, AUI you call it, and it tells us the power output. It tells us the modulation. Can we rely on that?
Should be able to, yeah. So the output power on that, and I've had FCC inspectors tell me that it was more accurate than anything they'd seen. But the output power on that is calculated from the final stage amplifier volts and current with compensation for phase angle based on reflected power. So it should be pretty close to calorimeter accurate, And that is how we set it up. When we set that calibration scale in the software in the factory, we're comparing against a calorimeter calibrated load. So we have a pretty good idea what we're doing there.
Hey, Jeff.
Yeah.
Yeah, Mark, your KLUX out. I still have an external bird in the line just because that's something, outside of the transmitter that,
Yep.
and they don't read the same, identical, because I have an HT going. Right. And the bird doesn't know HT, it just knows total energy.
Mm-hmm.
But it's still useful. The idea is, at least in my brain, is if they start differing by more than what they normally differ, I would start looking for a problem.
And that's the question, Mark. Jeff, you want to repeat what we talked about the other day about putting a string of birds together?
That's exactly where I was going. We had a situation once. I was at a site, and don't see anybody here from that site, but because if they were, I'd call them out on it just for the fun. But we had 6 Model 43s, through-line, just regular through-line watt meters. We put the 6 of them chained together in a row with end connector barrels to a dummy load with a 50-watt exciter. And we got readings from 25 watts to about 120 watts.
Yeah, it's pretty crazy. The other thing I was going to mention on the airplane in the FAA is I have a transmitter that I no longer work on, but it's still out there. It's a BE tube transmitter, and it's real near the flight path. And occasionally I'll get a call, hey, we're hearing the music from your transmitter. And the first time it turned out to be an oscillator in the STL receiver. Nothing to do with the transmitter, because I shut it off and they said it's still there. That was kind of funny. But the other problem was, depending on how you tighten the door, you could make it come and go. If you tighten the top first, it was perfect. If you tighten the bottom first, it would oscillate, or they would detect it, whatever you want to say.
Oh, cool.
So you always have to tighten the top screws first on the PA cavity.
I wonder if you were just changing the frequency to someplace they weren't listening. And then also on power on power meters, it was interesting what you were saying about looking at the final amplifier. I thought that the output power would normally be looking at the transmission line. And then if that meter were to go bad, you'd see variation in efficiency, because your meters are not going to all fail at once. So I would expect, if your efficiency changes, something's going on, and figure out why. On the birds in a row, I did the same thing with thermocouple ammeters for AM, and they read all over the place. They agreed perfectly at 60 hertz, but not at 1 megahertz.
Yeah, and the only way you will get to, and I mean, I'm perking on birds. It could be coaxial dynamics. It could be any capacitively coupled watt meter. But bird's the most common name. It's the one I happens to come to mind most. But anytime you have 2 watt meters and any reflected power at all, you're going to get different readings unless those watt meters are exactly half a wavelength apart. And how often does that happen in real life? About never. So yeah, like Mark said, you get your 2 watt meters and you see your readings, and you've got a reasonable assurance that those are this is working normally readings. Then you look for changes, and if anything deviates after that, like what you're saying, Harold, with the efficiency, then it's time to start digging.
The other thing with an external watt meter is once you remember, it reads total wattage, including spurs. And your clue there is, as he was saying, efficiency. If your efficiency changes, find out why.
Yeah.
Because now it's taking more energy to make the same watts. Whereas, why is it taking more energy?
Over the years, most stations don't bother to have spectrum analyzers. Directional stations will have their field intensity meter, or they used to. But even with the MOM, one of the best ways, I think, Jeff, you'll agree, to check your efficiency and check your meters, know where one of or more of your monitor points are, and find out what your radiation is at a kilometer or at a mile, and keep record of that.
Yeah, I mean, that one, there are so many things that can impact field strength, though. I mean, if you're looking at an AM, just a wet day versus a dry day will have an impact on that. So that can be a little, but again, it's something that as you do it more, you get used to the things that will cause it to change.
Exactly.
And so you sort of automatically build your own mental correction curve, if you will. And I think that's the big thing. And this is, if I was a fly on the wall, my guess would be this is the reason that the FCC went from requiring logs every couple hours or whatever it was to as often as required, because it is going to be situational. If you're running a 25 or 30-year-old AEL, then you're probably going to spend a lot more time watching meter readings than if you're running a 20 or 30-week-old solid state, pick your favorite brand. Of course, I'm somewhat biased, but
no, couldn't be.
No, it's hard to believe, isn't it?
Bill, what's up?
I just wondered, Jeff, the spectral occupancy, the kind of mini spectrum plot, is that sniffed from the same coupler as the power, or is that predictive from the DSP, or is how much is that?
It is based on the exciter output. It does have feedback from the pre-correction circuitry that we use also in HD radio. So it has some correction for nonlinearities in the antenna system. But yeah, it is not going to be the end all be all as far as channel bandwidth goes. You're definitely not. you know, there are situations where you could, I mean, maybe you got some tower climber stepped on an antenna bay and threw your tuning off. So yeah, in a good load, it should be really accurate. In a bad load, again, all bets are off because it is optimized at the exciter output.
Well, and where you put it in the chain is so important. As you said, if they're not in the right place, they can read virtually any number you want.
Yeah. Oh yeah.
Another thing we started metering a while back for us is both voltage and amps on the input to the radio. And that's another set of clues. If something changes, you know, the amp meter I have is accurate to one count, so you can be off an amp, you know, day to day. But if it changes 5 or 6 amps, I start looking for a reason.
Yeah, and that comes back to what Harold was talking about with the efficiency before, because if you've got your
same idea.
Exactly.
But that again, that's something external to the transmitter. So, you know, anything in the transmitter can't affect those external meters.
Right. Yep. And it's not a bad idea to have a voltmeter, or you can get inline power meters. I mean, some of them can get a little spendy. The Fluke ones are up over a couple $1,000 a pop. But there are lower cost power analyzers that, you know, clamp on current meter, and a voltmeter is basically all you need.
Mm-hmm. Yep.
So. And that comes back to, you know, we had this, I had this conversation, and not to let too much out of the bag, but the SBE, as part of the ongoing education series, is doing a troubleshooting course. And we were talking about that the other day, and one of the things I was mentioning was it used to be, if you wanted to take a look at a potential issue up the pipe, you were hiring a tower climber who'd grab his favorite brand of dish detergent and head on up and look for the leaky spots. And nowadays, I mean, for less than $1,000, you can disconnect the coax at the transmitter output and hook up a TDR and know exactly where things are sideways.
Unless you're on Mount Wilson.
Some of those cheap TDR things that are USB dongles are pretty good. I've compared several against the real instruments, and they'll get you in the ballpark.
Yep.
Speaking of AC power monitors, I haven't had a look at it, but for $165 is something called the Emporia Monitor Circuit Electricity Metering on Amazon. And it has 16 50 amps current transformers, 2 200 amp main current transformers, and Wi-Fi interface, and so on. So it'll give you a log of power from each circuit and the main. So amazingly cheap. I haven't tried it, but it looks interesting.
Could you throw a link up for that in the chat, Harold? That'd be something that cool. I'm sure somebody somewhere will give it a shot.
I will put that out there.
I'll just mention that some time ago, I worked at a station that was running a field intensity that was less than one would expect. Let's say about 20% less than one would expect. And after going through the transmitter and checking everything else, there was a thermocouple meter that was reading high. And after replacing that, field intensity jumped 20%, station sounded better. But it shows the need to keep your eye on these things, that as time goes by, lightning chokes get burned out. Other things happen along the way. Capacitors do change value a little bit here and there. But it's important to know what your power level is from your own investigation, not just a quick look at the front panel of the transmitter. Modulation, Jeff, how's that one?
So again, the ones we put on are really accurate. There are some caveats to them, and Bill will have seen this with the VS. Depending on software, at one point the modulation meter also read the pilot and the the RDS injection levels, because it was just reading total modulation across the band. So I could totally kill my audio and still see 11.5% or 12% or whatever I was doing for injection levels. So, you know, it's one of those, again, you need to know what you're starting with. And once you've got that, then for your particular situation, you need to figure out how often is best. Now, then the person I want to throw this at, and I'm going to wait till he puts his drink down so he doesn't spit it all over. But Mark, you've got a boatload of stations. So how do you make sure everything stays there? You got to unmute yourself now.
Yeah, no, I was trying to look for the X. All right, so run the question by me again, because I'm kind of all over.
Well, I said, so, I mean, you know, on a solid state, I might go a little less. On an older tube rig, I might go a little more often on my meter readings. But when you've got a whole bunch of them, how do you keep track? How do you know how often, or has it been looked at recently enough?
You know, that's a tough one because we're so spread out. We're across the state of Nebraska. We've got 14 signals here in Nebraska alone that I look at. I try to on the what I call the higher powered stations, especially the two that have tube rigs. The one here is local, so once a week for that. The other one at least once a month, because we also have a generator that I have to maintain on site. The rest of the sites are all solid state. 1 to 2 months, depending on if there's things going on or not. You know, if I've got issues with something, then obviously I'm not going to get out as often as I'd like to. I guess that's it.
Yeah, and again, it's like I say, it's situational both on the site and on your own schedule. I mean, and that's the challenge. More and more, and I like Bill's idea with the SNMP monitoring, because if you've got IP access to a site,
well,
you can automate all that.
And that's the other thing. See, I've got monitoring to everything. So, you know, I can pull up any site on the computer or on the phone and be able to see exactly what's going on. Usually try, if I'm in the office here, I do make it a point to go into each site and just take a basic set of readings, you know, forward power, reflected power, PA voltage, PA current, temperature in the building. That's about it. And, you know, if I see something that doesn't look right compared to earlier readings, then of course I'll address it. If it requires a personal intervention, then it's jump in the truck and go out to the site. But, you know, for the most part, I do have some SMTP stuff going. But eventually want to get everything on that platform so that, you know, alarms and that sort of thing will come through more easily than what I get now. I just rely on remote control units to send me any kind of alarms. So, you know, making it a point to just get in and just look at things on a daily basis is, to me, is pretty good.
And I mean, that's just, I'm going to beat on Bill a little for the SNMP, not beat on, but kudos, because like this, for example, you can barely see it, I know, over the laptop camera. That's the PRTG is telling me that the thermostat at the house is reporting high humidity, which is basically a polite way of saying my wife has got the windows open and it's raining out. Because that's we finally gotten below 80 degrees for the first time in a lot of weeks. But again, yeah, you know, you can, if you've got IP connectivity, that's a really easy thing to do, and you can get a basic, and I mean not to plug anybody in particular, but you can get a low-end Max Connect for what, 60, 70 bucks a month.
We're going to look more into SNMP and programming over the next couple of months. In fact, we may be arranging some tutorials, sessions, and we want to talk both about security, firewall and security, and actually control. There was a little press release today from WorldCast that they have made some of their software standalone for controlling different sites. And so I think there's going to be more and more interest in this, and we'll see what we can do to share that information with everyone.
My predecessor at KLUX set up everything SMTP between a Burke Touch Plus and the Nautel. Just works. And then we pay for like $20 a month for a mail service. So I get mail to text. So I get text messages whenever something is out of tolerance that the Burke is capable of detecting. So that works out real well.
Well, one of the really nice things about using something like MRTG, which is just a grapher, really, and it takes your readings and graphs them.
Mm-hmm.
But you can, you get a report from some board op that said something funny happened last night, and when I dialed up that reading, it looked okay, but then it came back a couple more times, but I never got a chance to catch it. If you've got something like MRTG that's running a graph, you can see things gradually change, still within limits, but gradually changing towards bad.
Yeah.
Or you can see the thing that happened 15 minutes ago that the board op just got around to checking the meter reading on, the glitch, the spike, the SWR going nuts for a second and then going back again.
Yeah, I'm using the Burke autopilot stuff for long-term analysis like that. And also have a real nice screen that the operator can just look at, and all the information is summarized there. They don't have to know how to drive anything. They just look at it. And there's two big buttons on that screen that say off and on. If you want them to turn it off, they can do it.
Okay, Mark Morris, I saw your hand.
Yeah, I just wanted to tell Harold, thanks for that link, because that's just exactly what I've been looking for. We just put a station on out in the Panhandle, and of course it's at a site that's not very well accessible. And we're having to pay extra for power as well as the lease for the site. And I've been looking for a way that I could monitor the usage, the power usage of the transmitter, as well as everything else in the rack. So thanks, Harold. That's awesome.
Yeah, it showed up on another mailing list I'm on. A couple of things with automation. I think it can be near continuous monitoring of all parameters. And you don't really want to be logging identical things over and over again. It just takes a lot of space. But maybe do logging based on a certain percentage change of anything. And the system automatically do that and do alarms and generate graphs and so on. And then also back a few minutes ago, there was a little bit of talk about field strength readings, which reminded me of equipment performance measurements and the requirement on directional antennas. And there's a requirement that I think is very strange. If it's a directional, you're required to measure in the major lobe, which makes sense, but the reference is the non-directional field at that location. So if you've got 6 dB gain there, you've now just lost 6 dB margin in your spurious emissions. So I don't know if anybody knows that section exists. They probably are referencing the directional carrier at that location, but the rules specifically say the non-directional field strength.
Well, good. Okay, we've covered power and modulation a bit. Jeff, let's talk for just a few minutes about spurs and things that someone mentioned the ATC, the FAA calling. What causes that, and what should you look for? Let's just say if you don't have a spectrum analyzer in your back pocket.
So that can be a whole lot of things. I mean, I've seen spurs that were being caused. I saw one in one case that was being caused by a bolt arcing on a ground kit on an FM. I mean, that's probably more the exception. Typically, anytime I see spurs, it's usually going to come back to an amplifier or a switching supply that's gone sideways or an exciter problem. If you don't have, and even if you've got test equipment, I mean, all you can do with the spectrum analyzer, for example, you can tell, okay, it's coming out of the transmitter, or no, it's not coming out of the transmitter. And if it's not coming out of the transmitter, then it's obviously being generated after the fact, whether it's a load, whether it's, in a lot of cases, and picking an FAA as an example, Intermod's one good example, Harold. FAA, a lot of times with the 5G stuff going on, a lot of it isn't so much that you're kicking out a signal that's overload or that's out of band. It's that either they're trying to pull in a signal that is way below your noise floor, or your fundamentals overdriving their receiver and they're creating the interference in their own receiver. So it is good to be able to put the transmitter into a load on a spectrum analyzer and say, okay, yeah, we know we're clean coming out of the box. But it takes a little more. The worst thing you can do, and it's a hard call. On the FAA, it's a little easier because if they call, you pretty much have to shut it off or figure it out fast. But if AT&T calls, about the worst thing you can do is shut it off, because they'll say, yep, see, problem went away, it's all your fault. So you really, there sometimes need to be more politics than engineering involved with spurs.
I'd like to mention something that happened to me a number of years ago when I got a call from the FAA, and they said, we're hearing music from it was KACE on 103 point, what was the frequency? 103.9. And I thought, oh dear, FAA, they're going to make me turn off the transmitter here in Los Angeles. I sure don't want to do that. So we investigated, found out nothing was coming out of the transmitter, went over to the FAA building, which was very close by, and took up to their antenna, looked at it with a spectrum analyzer. Sure enough, there was a signal. So they happened to have a spare antenna. We hooked up to that and there was no signal. So we put that antenna on their receiver and everything was happy again. So apparently their antenna was corroded and that's what was causing the problem. It had nothing to do with us. It had to do with the FAA.
Yep, and I've run into that a lot. Greg makes it a good point here about AM and FM intermod. And I've chased those sort of problems several times. Test-wise, getting back to the original question, I mean, without a spectrum analyzer, it's really hard to narrow that kind of problem down. You pick something and put in a new thing and then just start doing that until the problem goes away. And that can be a really expensive way to troubleshoot a problem, especially if you're talking a big transmitter. So, you can swap out the exciter and that's usually relatively inexpensive, but an HD exciter, for example, is going to be an $11,000 replacement. So again, I think the analyzer is at least the best point to discover whether you're in the transmitter or out of the transmitter.
And there are now cheap spectrum analyzers. There's one for, was it $70 on Amazon that you can get? It's not good for an NRC, but it's certainly good for looking at the spectrum.
Right, and again, it comes back to the same thing what we were talking about with the power metering and with the TDRs and stuff like that. You don't need lab quality for this. You just need a relative reading. Oh, look, I see something here. Oh, look, no, I don't. So it's like I tell people when you're, and I'm going back to 5G, if I'm troubleshooting to find out where, like cabinet radiation, if I'm trying to find cabinet radiation out of a transmitter, any old cheap circuit board 900 megahertz Yagi will do the trick just wonderful. Connect it to the analyzer and just wave it around, because I don't need to know exactly what the level is. I just need to know where the hot spot is. So, I'll wave it around till I see a spike and it's like, okay, that's the thing.
Where it's coming from.
Yep. And I mean, the same deal when we're looking for spurs, there's a little bit of fox hunt methodology involved here. I mean, you don't, You could grab a receiver tuned to the spur, put some attenuation in front of it, and just wave a little directional antenna around till you see where the signal seems to peak, and then start chasing in that direction.
Mm-hmm.
And,
Greg asks if you have a co-located AM and FM, watch for FM spurs that are plus or minus AM carrier frequency. Found that at a station with poor grounding and a lousy composite connection to the exciter.
Yep. Yep, you can get the AM RF onto the FM. I had one where I was chasing FM audio on an AM transmitter, and that almost never happens. Turned out they had a bunch of capacitors bad in the exciters, so they were modulating the FM quite nicely. This is me trying to pour a thermos of water into a bottle of water without creating a flood in my office. So somebody talk about something intelligent for a couple of seconds.
Ray,
speaking of inexpensive spectrum analyzer, here's a tiny essay that I won in a raffle.
I'll be right over to get that. Ray says, have to be careful with high power and spectrum analyzers. Intermod and harmonics can generate in the analyzer front end.
Yes, and
yeah,
that is a really big one. Even with a good quality spectrum analyzer, you can't rely on the internal attenuation. You need to notch out the fundamental of the carrier you're measuring. Because if you're not notching that out, then you are almost certainly going to be creating. And the fast way to test it, if you've got like a 10 dB pad or a 10 dB, beyond having a tunable notch, which is the best way to do it. But if you got like a 10 dB, the little BNC attenuators, then plug one in and you look at your spurs and you look at your fundamental, and if they all go down 10 dB, then you're attenuated enough. If the fundamental goes down 10 dB and the spurs go down 20 dB, you're creating the interference in your analyzer.
Good point.
I've seen the front end of those little tiny assays get overloaded with a lot of RF. Because I've got one and I fired it up out at the site out in western Nebraska, and yeah, I overloaded it.
It's the same as with the even with the budget, even with a good TDR. I mean, if you connect a TDR to an antenna receives as well as it transmits. So if you've got something else on or near frequency within radiating distance, then you can potentially, you can blow the front end. My all-time favorite was standing in the driveway at a 50 kilowatt AM site on a fairly damp day when the ground conductivity was at its optimum, and hooking up an FIM41, and I forgot to adjust the volts per division or the millivolts per division first. So when I first turned it on, I was at like 10 millivolts per division instead of 10 volts per division. And it made this squeak sound, and the needle went flying all the way to the end of movement and wrapped itself around the pin a little bit, and that meter never worked again. So yeah, definitely always start with the highest reading and work your way down.
Let's take one here from your history mind, your memory. NRSC for AM is done every year. Should be done every year, unless stations trying to skate. With FM, you do it when you install a new transmitter or an exciter. What would you recommend over a period of time? Do you think someone should go in there every 5 years, 10 years, every 6 months and check what his FM is doing?
I think that it's a good idea, at least on and I like to do, a full tilt mic to antenna sweep of everything every couple of years. I was going to say twice a year is a little much, but every couple of years, because antenna systems will change. I mean, whether it's coax wearing through, whether somebody took a shot at, and if you got a foam filled coax and somebody took a shot at it, you won't know unless it fills up with water, but it can still change the operating characteristics in between. Ground kits, tower crews and Notorious was at a site a couple of weeks ago where the ground kits, every single wire was sticking out about 6 inches from the tower. They put up a new coax and never bolted a single ground kit to the tower. So, and that was in your backyard, Mark. Not specifically your backyard, but in your neck of the woods. So if whoever doesn't know, I was in Nebraska a couple of weeks ago for the Nebraska broadcasters, and I get to go see a couple of sites out there too, because that's the fun part of my job.
What happens to FM transmitters over a period of time that you have seen that we should be on the lookout for?
So it's going to vary. I mean, it's very, and you know me, my favorite word in the world is situational, but it is going to vary a lot. I mean, a tube transmitter, obviously you've got tubes that'll go soft, and then parameters will change. Any transmitter, solid state or tube, you may have electrolytics in the power supply that can get soft and start to develop some ripple. If you've got switching supplies, doesn't matter, they may still have them. So, you know, that's something that you can kind of keep an eye for. You can actually scope your DC voltage and see if you've got any kind of ripple on it. And again, having a benchmark set up right after you get the box, at that point, then you've got a reference. Because then if you come back in 5 years, say, oh, I've got some ripple here. Oh, what did it look like 5 years ago? Oh, yeah, it was there then too. Okay, never mind. You know, so that's the big deal.
Okay, let me narrow it a little bit. Let's talk about a Nautel solid state transmitter.
Same deal, same answer. Yeah,
you don't see tubes going bad in those.
You don't, but I'm still going to want to keep an eye on the power supply voltage to see if that's changed over time relative to the AC. I mean, if my AC goes down a little, then I would expect my power supply actually to go up a little because it's going to want to compensate. But again, assuming the same AC voltage, I should see the same DC voltage. I should see the same plate current. If those change at all, then I want to look at the efficiency. I want to look at forward versus reflected. So again, just a good overall set of switches. OBW is occupied bandwidth, Jerry. So you just it's a good way of you're looking at the power within your signal, and if there's any spurs or anything or harmonics, then you'll tend to see that that power level, that bandwidth, the amount of power in the channel will go up a little, even though the power on frequency is not.
You raise a good issue when you talk about the power supply. I don't know if you'll acknowledge or suggest that that's one of the weakest places, but I know that with Nautel supporting every transmitter they've ever built, one of the hassles has been power supplies that cannot be intermixed.
Yeah, and not just power supplies. I mean, you go back to the old amps, we had power amplifiers where we'd change from one FET, or I'll give you an example, the AmFET 50, 25 and 50, going back to 1984. We used an IRF 140 MOSFET. International Rectifier sent us a new batch of FETs, all IRF 140s. They changed from generation 1 to generation 3, but as far as they were concerned, IRF 140s and IRF 140, and it would have been, except the generation 3 had double the input capacitance. Well, on an AM circuit, that has a slight impact on the tuning of the module. So, you know, again, this is the kind of situation we run into on the daily. So yeah, I mean, trying to find stuff like that. UG69 power supplies, the first iterations had, I'm going to be polite and say a less than optimal reliability rate based on what we've come to expect in our design. The later ones are a whole lot better, but after you blow up enough in the field, people start to get a little gun shy. The new ones, the UG132s, are even more reliable again, but if you've got a UG69, you can't plug and play. There's an adapter kit. So yeah, this is where it's incumbent on us as manufacturers to keep track of what we have and what's out there. And that's why when you call customer service, one of the most annoying questions they ask, and one of the most important, is what's the serial number? Because if you give them the serial number, they can go back and tell you exactly what was in it and if they ever shipped replacements, et cetera, and so on. But if you just tell them, oh, I've got an NV10, well, then it's a crapshoot what you're dealing with. So
back with vacuum tubes, I think that was clearly the least reliable part and expected to fail. I think now it's probably electrolytics, and then anything else is probably, you know, like lightning damage or something, but it doesn't necessarily have a planned lifetime for any other component where, you know, we expect it to only last 10 years. Is that the case? Or?
Not quite. Yes and no. I mean, yeah, we don't design a lifespan for certain, and there are things like plate blockers you would expect to see fail on occasion. But you're certainly right. It wasn't a timed consumable, something that you expect to see every so many years. But even now, and again, regardless whose you've got, there's going to be fans or blowers or coolant pumps, and those things do have a specific life cycle. So it is a good idea when you get a new box to kind of talk to your sales rep's going to lie to you anyway. Yeah. But no, to talk to your sales rep and say, you know, what are the consumables? What are the things that I can expect to see fail over the next 10 or 15 years? And, you know, what should I stock or what should I allow for?
That's a good question, and one that should be asked, one that should be answered. And it's different, you know, 30, 40 years ago, there was a rule about how many spare parts you had to keep on hand. And then we got to where that was taken out of the rules and stations declined to buy the spare parts kit.
Yeah, and keeping in mind too, though, back then, almost any part failed and you were off the air. I mean, these days you lose an amplifier, you may or may not even see a reduction in output power. You lose a power supply, it could be the same situation. If you lose an exciter, that can be a little more critical, or an IPA, or. So again, my favorite word, situational. You know, what you stock is going to be determined in a lot. I'll give you an example. I got one customer, he's got 5 stations in his market. All different transmitters, you know, some of ours, some others. And then he's got a 2.5 kilowatt with a Jam Pro penetrator with single bay on a telephone pole at the studio. And that VS 2.5 will back up every single one of his 5 stations. So he carries no spare parts for anything except the VS 2.5, because he says that's the one that needs to run no matter what. So, you know, again, yeah, it's definitely going to be a sort of situation that you determine based on your own specific circumstances. Ray's asked about lifetime predictions for caps in VS series when always operated in 78. So number one, on the VS, the only electrolytics in that box, I think there's a couple on the power supply distribution board and maybe in the switching supplies. There's a Meanwell and a, depending on the vintage of the transmitter, either a Tektral or a Lineage. Sorry, Lineage is now ABB, but the new supplies are all ABB. Anyway, 78 degrees ambient, well, the nominal lifespan for a cap, typically they're spec'd at 40 degrees Celsius, which is 104 Fahrenheit. And as you decrease that, you increase lifespan. At 78, you're probably, if I was, and I'm throwing a dart at a board here, but I'd assume 15 years at a guess, maybe more. You know, and some of it comes back to humidity as well.
And that's 78 ambient, and what it is inside the transmitter is a different thing.
That is correct. That depends on your airflow and a whole bunch of other stuff.
I think it's something like double the life for every 10 degrees C you go down from spec, something like that.
That's just about exactly and that works for both electrolytics and mechanical blowers or fans.
But Jeff, solid state transmitters are supposed to run forever.
Current goes through it, current will stop going through it at some point.
The points get chipped on the transistors.
Yeah. So yeah, I have never ever been the person that said a solid state box will run forever any more than a tube box would run forever. You know, properly maintained, kept cool and clean, it'll run a lot longer. But no, there's always going to be stuff. So you know, our goal is just to do the stuff like the meter readings, so we can see the big things like the antenna or a potential filter situation before we get to because those are the ones that will take you down in flames, quite literally.
So as a manufacturer, you are hearing problems from the field and shipping out replacement parts. What is the most common thing that goes wrong and needs to be replaced?
Most common thing that goes wrong on, I would say probably power supplies. And of the power supplies, even today with the current supplies, which are easily 10 times as reliable as the original ones we were using. And I mean, we've got the field data for that, but even with those, if the site's not properly grounded with the surge protector, those supplies are the path for lightning energy to get from the tower to the AC lines. And, you know, so that's what you're going to see fail more than anything.
Would you say the biggest problem are certain people who refer to themselves as radio engineers?
No, I mean, I've seen some engineers who I knew to be really good engineers so do some really dumb things. I mean, you're talking to the guy that X'd out the whole meeting a couple of minutes before we started. So, you know, I don't judge. I've seen some really what I would call backyard mechanics who had some really nicely laid out sites. So I don't think it necessarily comes back to the engineer. I think that the current trend toward having folks who are more IT oriented with a lot less high voltage and current experience doing the maintenance can be a challenge sometimes, because they don't understand that when a lightning hits the tower, there's a lot of amps looking for a place to go.
Lack of training.
Lack of training. Yeah, I don't, you know, I don't think that we've got any more good or bad engineers than we had 30, 40 years ago. I mean, as a per capita, as a ratio. But I do think we've got a lot less experience when it comes to the big volts out there. And that's where we really need to try to help the younger folks as much as we can.
A failure of management to understand that there's some value to paying for somebody with some experience.
Exactly. Yep. Not just that. I mean, some of it comes down to availability. I mean, I can tell you right off that I've got states where I've seen stations off the air 3 or 4 days because there just wasn't an engineer available. Not that they weren't willing to pay. There was just nobody there. I mean, they're all, you know, as we get older and the field thins a little bit, and the younger folks look at this and say, why would I want to get paid $50,000 a year to be on call 24/7 and never take a vacation again and get called out at all hours of day and night when I could work in IT for $80,000 a year and shut the pager off at 5 and go home. So yeah.
Do manufacturers ever do things like do training courses? I mean, that used to be a thing when you bought a whole bunch of somebody's something or paid a whole lot of money for it. You could send somebody from your staff there and they would teach them where not to stick their fingers.
Yep. We still do it. Gates Air, I know for a fact, still does it. Rhodey just finished building a new training facility in Maryland. So all of the bigger, and I think BE does, I don't know anybody there anymore, so it's hard for me to say. But yeah, all the big manufacturers still do offer factory training. Some of us, we're working, and I mean, I'm on the SBE education committee, so the SBE is also putting a lot of focus on this. And it doesn't need to be product specific. I mean, you know, you don't need to know exactly how to work on a Nautel VS 2.5. You need to know how to work on a 2.5 kilowatt transmitter in general. And that's one of the things, like I say, the SBE has just started. I think they're on session 3 of 8 of a several month troubleshooting course. And it's not about how to fix anything in specific. It's looking at different scenarios and learning how to troubleshoot in general, you know, learning the concept of troubleshooting, because that's the stuff that we all sort of grew up doing, and the kids today, they're not, you know, they don't have that. They didn't have the Heath kits or the, you know, in my case, the first electric fence in the neighborhood to learn on. And I'm not going to tell you any more about that particular scenario, but let's just say that's a lesson I'll never forget.
Did you get a charge out of?
Let's just say that my hair stood up and something else didn't.
Oh,
I was working with a power company in Colorado on an RF interference issue, and the guy, they were great, and the tech that they sent out told me about a electric fence that was radiating, and the owner wouldn't let him shut it down, so he had to turn the fence owner over to the FCC.
Yep. That garage door openers, there's been a whole bunch of stuff over the years. I had one situation, well, radar detectors were always really good for messing up STLs.
Yeah, they jammed credit card machines in gas stations, I think, for a while with the satellite links. And remind me of something else. Oh, manuals and theory of operation. Used to be, you know, I'm scanning all these old manuals, and they're very good, large theory of operation sections, which really help you in troubleshooting. Is that still the thing, or is it more like an iPhone where you keep poking at it until it does what you want?
So I just got assigned a company iPhone about 3 or 4 months ago, and it has been my nemesis, if you will. And a lot of people are, oh, you'll love it. And it's like, you know what? 4 months later, I still don't love it. I don't hate it. It's just a tool. But yeah, no, it's that one will depend on the manufacturer themselves. Like if you go to one of ours, we probably do less on the actual electronic theory of operation, although we do still provide some, but we do a lot more what we call purpose-oriented documentation. So if you go to the troubleshooting manual, there will be a big table of alarms, for example. And you go through that and it'll say, go to this page or click this link. And then it'll say, so this is what normally causes this alarm. This is where to look. This is what you should see. So we do a lot more of that than the voltage at C92 and R14 should be this level because this is what biases this transistor to do this function, which is the way the older books were written. So, you know, if you read one of our old manuals, you could pretty much design one of our transmitters. So with the newer ones, less so, but you're going to know how to fix it.
we're coming up on an hour here, and I know, Jeff, you're going to demurely tell us you need to move on because you're only an hour ahead of everybody else out there. But before we do, if anyone has a question for Jeff on Nautel or making sure your equipment is up to stuff in general, please raise your hand or let us hear from you. And Jeff, next Tuesday, is it that you are going to do one of your Tuesday deals?
Nope. We're coming back on the 13th.
Okay.
13th. Yeah, because next, oh, wait, maybe that, no, that's not next Tuesday, is it? Please don't let it be next Tuesday. No, it's not. Okay, so the 13th, we're doing 3 in September, and we're going to get a little, we're not going to beat you over the head on them as much for the next few months, partly because I've been on the road so much that I don't have time. But the 3 we've got in September are, I want to talk about repair or replace, because that's something we all struggle with. You know, when are you spending more money fixing it than you would just buying a new one, and how to make that call. And so for that one, I'm trying to get a group manager, engineering manager, and his owner on. And if I'm successful with that, then we'll be able to get it from both perspectives.
Maybe we could replicate that next month here too.
Sure.
That's a very good issue. ROI is so important, and yet.
Well, right. And I mean, there's cost of operation and then there's cost of ownership. And the two, while related, are not 100% the same. Ray had asked a question earlier about a ground resistance measuring tool. And I've got a link for one somewhere, Ray, but I'm going to have to do some hunting to find it. So I'll try to do that and get it over to Barry. And Barry, maybe you can post it up in the YouTube link in a couple of days.
Okay.
But that'll be my list of things to do. There are some out there. Let's see. Bill worked on a Tesla coil for a. Oh, okay, yeah, killing the middle marker at the airport. Little details like that. Yeah, anything.
Turns out if you change the loading on the output of a pre-running oscillator, it changes the frequency.
Yeah. Well, and that comes back to my biggest story about the AM that I was installing, and then we started doing some training on, and I was showing how you could pull the crystal out and it would kill the transmitter, and it would flip over to the backup exciter and come right back up. But it was one way one time, so if you pulled the crystal out of the backup, it would just go down and stay down. And then when I went to reset it and bring it back up, I forgot, and I plugged the crystal in while it was coming up, and discovered that crystals don't start off at their own frequency either. And that was an interesting sound, but it was all self-contained, mostly in the transmitter building with a lot of profanity.
Well, Jeff, on behalf of the 60 or so folks that have popped in here on Zoom and on YouTube, sure want to thank you for being with us and spending one of your first afternoons after vacation with us.
Yeah, that's right. August, well, it was 2.5 weeks on the road and then a week and a half of vacation. And so this week has just been shoveling out from underneath the pile that grew while I was not paying as much attention.
Are you going to Amsterdam?
I do not go to Amsterdam. I make it a point. No, I did 17 years of international field service. And so for the last 15 years, I've been working North America only. And it is so awesome to be able to wake up every morning and read the room service menu and not have to guess what this word means. So yeah, you probably won't see me. Now, never say never. Never is a long, long time. But I don't have any plans to be doing any more international stuff. You know, I'll stick to home as much as I can.
Still have to speak French though, right?
Ah, je parle un petit peu de français. Je hablo español también. So I can do it in English, Spanish, French, a little bit of German, and a tiny bit of Thai. But my wife wants me to learn Italian because she says once I retire, we're going to see Venice. That's the only trip she's ever wanted to make. So I guess I've got a couple of years to pick up on some Italian.